Hey everyone, Jake here from Buddy Tech, and today we're going to go over the three most important things you need to know before uploading any video of yourself to AI or computer vision. Let's get after it. So the first thing I want to talk about is how AI models see, or more aptly here, how computer vision models see. So much like LLMs are modeled after the human brain, computer vision models are modeled after how humans see with our eyes. You might not realize this, but you're constantly seeing images and light refraction to interpreting that with your eye and then with your brain. AI kind of has to work the same way. To put this more simply, when you upload a video, it's not like AI is watching the video and just making assumptions. What it's actually doing is it's breaking that video into each of its individual frames and then looking at each frame, which is more or less a picture, and trying to make a prediction about what's going on in that frame. So for example, here you can see a video going on of a kid shooting a hockey puck. What an AI is going to do here is it's actually going to look at each frame and try and predict what is going on in that frame. So is there an arm? Is there a leg? Is there a hockey puck? And intuitively, this might seem really easy for a human to do just because we're constantly seeing the world around us and able to interpret it. But for an AI, it's a much more challenging task. So when it sees someone from far away, for example, it might be a little bit harder for it to understand what an arm is than when it sees it when it's close by. And the reason for that being is that there's a thing called pixelation, where it's not seeing quite the same way humans see. It's seeing pixels on the video or the image file, and it's combining those pixels in order to make an image that it's been trained on. For example, an LLM model might be trained on millions of pictures of what a human arm looks like. However, if the human's arm is far away, those pixels might blend in the arm with the body, which is why it might misinterpret that. Is that an arm? Is that a leg? I don't really know, because all these things are blending together. So that's the first thing that you need to know, is that LLMs or computer vision models can only see the world in images. So if you give it poor quality images, it's going to really struggle. The second thing I want to talk to you about here today is distance and speed, and why those are going to be a little bit trickier for computer vision models and as well as LLMs to interpret. So as we just talked about, we now understand that LLM and AI models understand the world through pictures, right? I upload a picture, and even if I was to text you a picture right now and ask you, how far away am I from this person? You're gonna have to make an educated guess. Now, you might use some markers. For example, if the person's on a football field, you'd be able to use kind of the yardage markers to make a guess there. But if they're just standing in the middle of a field, it could be a mile, I could be using Zoom. It's really impossible to tell. And the same thing is true of an LLM trying to make a guess about distance or speed in a video. So often in sports, or even for things like traffic, it's going to be tough for an LLM or an AI model to really make a guess about how far things are apart or how fast things are going when it's just looking at an image and then seeing the next image. It can map that, hey, this pixel was in this place and now it's in this place, and I know the road's this long, and do a math problem. The world's and how we film is uncontrollable. It doesn't really know where we're filming from, our vantage point, zoom, all of those things. So unless that's built into the prompt, or unless there's some standardized setting where it automatically is configured, asking an AI model, like, how fast am I running in this video, or how far away is this building from me, is going to be a really tough thing for it to do, because, again, it's understanding the world through frames. It doesn't have a full context, where the human mind, we can gauge these things, right? We can say that guy's going pretty fast, that guy's going pretty slow. Someone that's walking but actually looks like they're churning their legs and running could, in theory, trick an AI model to think it's going much faster than it actually is, just because it doesn't have any perspective of distance or motion. And this is doubly true of when you start moving the camera. So a lot of things that I see when people upload videos to our applications is they try and film the person as they move their hand and keep them center frame. Now, that's generally awesome if you're trying to do a highlight video, or you're trying to coach traditionally, send that to a human, because they're going to be able to normalize and they want to track. They don't want the person to fall out of frame. The issue with AI with this is that when you start moving the camera, it totally confuses like where the pixel positions are. So it's going to totally make it have no understanding of like relative position. So if you're asking it about how fast this person's moving and you're tracking them the whole way around like a track loop, it's going to have no idea, because it's basically going to think they're not moving almost, because it's saying center frame as well as having pixel moves. All right, and the final thing we're going to talk today about is the brain. So we've talked a lot about computer vision so far, how it interprets frames by looking for images and labeling those images based on its training set. We've also talked a little bit about limitations, like when the camera moves or you're trying to measure distance or speed, because there's just some known limitations around the models and what they can and can't do. So what we're finally going to do is talk about the brain, because this is where we've really seen a lot of breakthroughs in the last couple of years and why computer vision and AI are such a powerful combo. So LLMs actually allow you to look at those images and apply a knowledge base to it. So something like Gemini or Claude has been trained on millions of images. And it's also been trained on tons of knowledge bases about what those images might mean. So where computer vision can just see the knee is in this position, the components over here, and tell you exactly where it is in the frame, an AI model can actually make sense of that, saying knee bend good, component flawed, right? So the last part of this is when you upload an image or a video, thinking about the inference model behind it. So for example here, you might want to analyze your hockey technique. And I'm going to put a video up here of a kid shooting a hockey puck. Now there's a ton of things you could see in this video. You can see his body position. You can see where his puck is. You can see where his stick is. And some of these things are going to be really easy to track based on what we talked about earlier, if they're clearly in sight and they're clearly been something that a model has been trained on. Other things like the stick bending or the speed of the puck are going to be trickier, right? Because the images might blur together, or it might be hard to get that exact frame extracted. So when you're choosing an AI model and you want something really reliable for a workflow or a product, what's important is that you choose the right models for the right jobs. So for example here, when I'm first looking at this image or video, I could just upload it right to Gemini and say, tell me if my form's good. But what I could also do is use a specialized computer vision model. And these are coming out via RoboFlow and tons of tools now coming to market that actually allow you to train your own model, that instead of searching the entire internet of images and trying to label what's going on in the video, you can actually upload a set of images or clips that are labeled and just check against those. So now the model, instead of figuring out in every image, where's the person's head, where's their helmet, where is their feet, it doesn't have to look up every picture of a foot ever. It just has to look up from your training set it's been fine-tuned on potentially, and it makes it much more faster and reliable. Additionally, when you do inference, you can actually help out the model a lot. Instead of just prompting it saying, is my technique good? Is the puck moving fast? Give it some identifiers. Maybe the person's 20 feet away from the net, or maybe the person wants to bend their knees more. So if you abstracted in the previous model's call that the person's bending a lot because you know where their knee is placed and where their hips are placed, so you can calculate bend, now you can go ahead and pass that information instead of letting Gemini or OpenAI make a guess at it. So think of this as a workflow. Don't just throw videos into the abyss and hope they get labeled right. That's the fastest way to have our dreaded enemy, the hallucination, occur. Think of it much more like, how much data can I extract from this video via computer vision, and then how can I use an LLM and AI to actually interpret that data based on what we've identified or want to get out of that video. That's the final piece of the puzzle. You understand how the eyes work. You understand some of the limitations about how computer vision might fault or what you need to work around when trying to analyze frames of a video. And lastly, you understand how we can use these modern AI models to think and interpret videos and be a really powerful combination. So if you have a dream about how you want to change youth sports, feel free to reach out to me and my team at Buddy Tech. And I hope this helped you upload your videos moving forward, whether it be to LLMs or computer vision models. Thank you, and have a great rest of your week.